Alright, I'm doing the review straight from the assessment package, so if you missed something, you can catch it here. So in problem number 1, the first thing I'm going to do is I'm going to plug in the value that they gave me, which in this case was 6. So that's 31. That's 218 on the bottom. And since we didn't get a 0 on the bottom, this is just a number. The answer is continuous. In problem number 2, I'm going to do the same thing. We got 5 times 3 halves plus 4, which is 11.5 over 2 times 3 halves minus 3, which is 0. Since we got a non-zero divided by a 0, this is an infinite discontinuity every time. So what I'm going to do in problem number 3 is I'm going to plug in 1 into both of these. And for the top one, I got 1 squared plus 5 equals 6. 3 times 1 minus 2 equaled 1. And since these are not the same, the answer is a jump discontinuity. For problem number 4, we're looking for the term with the highest exponent, which is negative 3x to the 9th. Because 9 is odd, and this is negative 3, we always start out with x going to negative. Now, if you take a look at your calculator, you only really have to do this part of the problem. And when x is negative, y is positive. On the other side, when x is positive, when it gets very big, y is actually negative. For problem number 5, we have the same thing. And we got the 3x squared being the highest, which is even and positive, which means on both sides we are going to be up, which means I use positive infinity for both sets of y's. Remember, x going to negative infinity is always the left, x going to positive infinity is always the right, and those are always part of your answers, and this just means we're going up and up. Alright, when I graph this next one, I get something that looks like this and like this, so I need to change my window, and I'm going to change my window down. So for my window, I'm going to change the y minimum. And when I change the y minimum to equal negative 50, it goes low enough to see that these actually go up, connect. So at this point right here, I have a maximum that I need to find. And when I find it, it turns out to have those e negative 6's on the x and the y. So I got an answer of 0, 0. Over here I'm going to find the minimum. Remember, you do the left and then the right and then gap. And this point turned out to be 4, negative 32. And I'm only really concerned about the x value anyway. So my graph starts out increasing. And it increases when x is less than 0. And then it starts to decrease, starting at 0 and ending at 4. And then it increases again when we pass 4. When I graph this one, I have less of a problem. It looks like this and like this. And once again, I need to find the minimums. That was at negative 2, 2. And that was at positive 2, 2. And this was at 0, 6. Once again, the y values don't matter because we're just doing the x values where it's increasing and decreasing. So when x is less than negative 2, we are decreasing. And then we increase between negative 2 and 0, decrease again from 0 to 2, and when we pass 2, we are increasing. And remember, we're just looking at the x's and we're going from left to right. So decreasing, increasing, decreasing, increasing. For this particular problem, we're trying to find the extrema. So, since none of these are the highest or the lowest points, they are all relative. So, at negative 3, 2, we have a relative maximum. At 2, 1, we have a relative maximum, because those are the highest in those areas. Negative 1, negative 3 is a relative minimum. And 4, negative 1 is also a relative minimum. In the next problem, we have this again, where this point seems to be at 0, 0, and this point seems to be at 1, 0, and this point turns out to be at 0.5, comma 0.3 is my best guess. And so this is an absolute minimum, and this is also an absolute minimum because those 2 points are tied for the lowest point anywhere on the graph. This point is not the highest point, so it's a relative minimum. I will do the second half on the next video.